how Automation Studio is able to handle and to simulate this kind of system, I mean subsea system. So we're talking about a system for which some components are located at the sea level, other ones are located at seafloor level, and we can figure that there is intermediate level for which some components are located. The major difference in this kind of system than other one for hydraulic industry is that the ambient condition is depending of the depth where they are located, the components. So we talk about pressure, and we talk also about temperature and about the fluid properties at this different level of depth. So to illustrate this in Automation Studio, we have considered a really simplified circuit that finally illustrate, we think, the usage of Automation Studio in the subsea system. And you can recognize here, of course, a boat that will finally figure the offshore system for the pumping of the oil. And the oil is represented at the bottom of the screen by this black area. Sorry. We can see two mentioned here: sea level 0 meter and sea floor at 2,500 meters. So it is example for this depth, and we can adjust it in Automation Studio in the way we want. And we have to figure that all the components, hydraulic components, which are located above this sea level, we can consider they are surrounded by an atmospheric pressure. And all the components that are above the seafloor level here, we can consider they are surrounded by a hydrostatic pressure build that exists at this depth here, 2,500 meters. And between the sea level and the floor level, we could figure other systems, but just to simplify the explanation, I will deal only with this depth of 2,500 meters and the sea level. But you can completely figure how to do this at different intermediate level, like I show here. So the first thing we're gonna see is how we model pressure and depth in Automation Studio. So the pressure built because of the depth under the sea level is important for components which have to exhaust hydraulic fluid inside the sea. Also, it is important, this pressure is really important at this depth level for components which have mobile parts like cylinder, and which have to move some mechanical components, so there is hydrostatic pressure that push on these actuators, and we have to represent this. So we see that right now the ambient pressure is really important. In Automation Studio, to figure the depth in a system, we use finally what we call the customized reservoir. This component we can see here. This component is able, you are able to specify a specific height, but we have to think that the height now will correspond, will be equal to the depth, I mean the level under the sea. So in my example, I put an initial height of 2,500 meters, and its height figures the sea level, the sea floor depth. All the ports, we can declare many ports as we want. It is a builder, so I can create as many ports I want. And each time I create a port, I can specify the level of the elevation where is located, what elevation is located this port, or also we can specify how many liter or volume of fluid exists at this port level. So I have already configured for the example, and I have declared, I think, 6 ports that are really important for the, not really important, but to illustrate different pressure level. And you will see that when I start my simulation, right now, we can see different pressure, hydrostatic pressure that are built because of the simulation. And this pressure, of course, depends on the fluid that is used in the circuit, and I have used the water. So you can see that at different level, you can figure there is 500 meters between each level of each port. And to illustrate, we have based the color of the line upon the level of pressure. So you can see visually the difference. And also you have, of course, the value of the pressure itself. So all the components that will exhaust will be connected to one of those ports. So for the components which are located at the seafloor level, I use this in the example, these ports, and what you can see here, it is the hyperlink that are help me and to locate where I link this jump level. I mean this line. It is a shortcut to not draw all the lines. So here we have an exhaust coming from the cylinder is coming this way. And those exhausts here are completely all connected to this component here. So all the exhausts from, for example, the sequence valve, the pilot of this valve, meaning that there is a hydrostatic pressure that is acting on the side of the valve. Also, we will use this hydrostatic pressure to figure that there is a hydrostatic pressure that acts on the rod here. All these lines are connected to this post here. Now, at the surface, we can connect all the exhaust here to this port. But already we have in automation studio some, for example, pressure relief valve for the maximum pressure of the system at the outlet port of the pump that is connected already to the atmospheric reservoir. So we don't have at the sea level to connect to this port. Now, between the sea level and the seafloor level, we have to send flow and fluid to the subsea system. In order to achieve this, we have to, so we simplify the pump system here by a more electrical motor that is driven a pump. And this pump has already filled the system, and we can see already the pressure that is built under at this level. So we have a regulation of the pressure at 242 bar plus the hydrostatic pressure. We reach here the 484 bar. Here you can see that we have this pressure equal the pressure here because they are connected together. Okay, and we can figure this everywhere in the circuit here. We have the same pressure, hydrostatic pressure. So now to be able to model the flow from the sea level to the seafloor level, we have to use an hydrostatic line, because by default Automation Studio doesn't consider for the line elevation, because of course considering elevation add some calculation for the pressure, and we don't need this calculation, for example, for a mobile system that for which the elevation is at least a maximum maybe 10 meters. So we don't have to consider this. But for this kind of system, we have to consider the hydraulic line modeling. So what is this component? Finally, it is a line. You draw a line directly, but in the properties, you have to explain that you want to consider this line as hydrostatic. Just like, let's have a look. If I put this value at false, now I can no more edit give a value to the elevation because it's not considered by the simulator with this modeling. So now I want to consider this modeling, and now I am able to change the elevation of the line. Of course, the elevation has to be at least the value of the lens. So now we know how to figure the exhaust, the hydrostatic pressure for the exhaust. We know how to figure the fill of the oil, and you can see here that the pressure is building slowly, but is building continuously up to reaching the value, the accurate value. Now, if we want to go, we have this ambient condition based on the pressure. Now we have to talk about the ambient condition because of the oil. We know that the ambient temperature at 0 meter and at this depth under the water is not the same. So to figure this, we use in Automation Studio the ISO standard. I mean, we talk about installation and circuit ISO standard. It means that we can consider all this system as one installation, but in this installation we have at least two circuits. The one that is located at the sea level and the other one that is the second one that is located at the seafloor level. And for those two circuits we have different ambient conditions. So to figure this, I just have to open the project properties, and I will show you here. I will consider the hydraulic installation, and I have already created two circuits in the installation I have called BOP system. So we have the circuit located at the sea level, for which I put an ambient temperature of 25 degrees, maybe it's quite hot. So maybe 15, and the initial fluid, we can consider it is at the same temperature that the ambient one. And now, for the second circuit of the BOP system, I call it, the description is the seafloor level, we can figure a really lower temperature, ambient temperature and initial temperature. And for this system, you can see also, you can specify, so the atmospheric pressure remains the same. But the absolute vapor pressure, if you want to go into details for the cavitation simulation, and if you have the data required to simulate this, you can specify for the two installations the absolute vapor pressure for the fluid you are using for your system. So, as soon as we have two installation circuits, now we have to define how we consider a circuit, to a component to belong to an installation specific circuit. So, just let me show you where you can locate the apartments. Here you can see the location of a component. By default, it means we are talking about we are located at installation 1 and circuit 1. So let me choose this component. This component is currently belonging to installation circuit 1, for which the ambient temperature you can see is 15 degrees, and the second one is 5 degrees. So what I have to do is just to select my component here, all the components that are under this, located at this level, sorry. And here I'm just gonna tell it, now you belong to, if I select the component, it belongs to the second installation. So now we have different initial conditions for each component. Now, the way we measure the pressure in Automation Studio all the time will be relative pressure. This pressure will be relative to the atmospheric pressure. So, if I read here 242 bars, it means it's 243 absolute bars. And if we want to measure relative pressure relative to the hydrostatic pressure, we need to use differential measuring instrument. In order to do this, of course, we can use components from the library, but for validation, it's better to use a dynamic measuring instrument. And here I can figure, so I can put, for example, a dynamic measuring instrument here, and I will add the differential pressure of these two, between those two parts. And you can do this for each component everywhere in the circuit. So there is no limit to measure. So we can measure the pressure we want, absolute relative to the atmosphere or relative to another pressure, like the hydrostatic of the pressure we are located where at the level. It's the level we are located. For the pressure compensation, most of the component in Automation Studio has this sequence valve as a pressure compensation. I mean, this valve is affected by the back pressure, the exhaust pressure of this component. So if we have here, we know that we have, for example, let me just measure this pressure here. We have a atmospheric relative pressure of 200 bar. We have here, if I consider this one, most of them is a double, and we can see here that this valve will open only, you can be sure that this valve will open directly at the pressure. So let me just try, for example, to put this valve at 200 bar. So you see that this valve open around 200 bar. You can see here the different differential pressure. So most of the components are pressure compensated in Automation Studio. We talk about directional valve, about flow regulator. Finally, you can adjust the performance you want based on the working pressure, so you can figure the compensation very easily. You can use accumulator to figure to have pressure compensated reservoir at any level you want. You can use accumulator, you can use an accumulator, gas accumulator, mass accumulator, but you can also use cylinder, and you can make, with a cylinder, you can adjust the effort and put it variable, so it can be very useful. Depending of your need, you can use many components to figure this pressure compensated reservoir. Now, considering the effort that act on a cylinder, I have just considered one example for this cylinder. Here we can consider, I have figured that only this rod is the hydrostatic pressure is acting on the area of this rod here. So the area of this rod is, if you compare the roadside area and the piston side area, you can see there is around 20 square centimeter as a surface, and on this, at this level, it means there is 240 bars that act on this area. So it means we build a pressure approximately equal to 4,800 dk Newton. And to put this value constantly onto the cylinder, we just have to use driving force. And you can see here, I have put during extension and retraction a driving force. It means a driving force will push your cylinder, will make your cylinder move as soon as the ports are not locked. So it's like a mass with an inclination. So we have represent the hydrostatic pressure that acts on the area of the edge of the rod of the cylinder because of the hydrostatic pressure. So we have the equivalent force. And now, with this modeling, we are able to start one more time the simulation, and you will see how it's done in Automation Studio. Of course, I just put this illustration of this not butterfly valve, but this very common valve used in the subsea system, and the objective is to open, close those valves. So I put a part of the hydraulic control circuit and the main power hydraulic circuit here that will push, for which the cylinder will push this valve. And I just give an animation for you to see that Automation Studio is not only an analytic tool, but also could be a training and documentation tool. So I hope it answers your question concerning what are the capabilities for Automation Studio to model this subsea system. So thank you for your attention. See you at another presentation.